All right, so in this video, we're going to talk about the difference between average velocity and instantaneous velocity. So this video is designed to follow on from a previous video on average speed and instantaneous speed. So if you haven't taken a look at that, I would check that out first. There's also a previous video about displacement, which it also might be worth taking a look at, but I'm not sure that one is so essential as the average speed versus instantaneous one. So we're going to start off with some questions to pick up some themes that we have met before. So what I'd like you to do is pause the video now and have a go at these three questions you can see there. The letters that are in brackets are clues to help you remember the keywords that we're looking for in our descriptions of these things. Okay, so I'm going to assume that you've done that. So if you haven't, pause and do it before I go through it. So in terms of average speed, average speed is the distance an object has traveled divided by the time taken. So you can see this is why there was d, and t. So it's the distance divided by time. That gives us our average speed. In what is instantaneous speed? So that's often abbreviated to speed. So let's chop that out. So what is speed? So speed is an abbreviation for instantaneous. Speed is the rate of change of distance or the gradient of a distance versus time graph. So again, you can see we've got the things, the letters that are in our brackets give us the keywords that we're looking for here. That's why those are there. And then finally, displacement. It's the length and direction between an object's start point and its end point. And the V is there because it's a vector quantity. So let's just quickly show that using a diagram, which I think shows it a lot better. So let's say the object started here and it ended here. The displacement would be the length of this vector and the direction of that arrow. That would describe the object's displacement. Okay, so at this point, you might decide that it's better to jump back and have a look at some of those previous videos to give you a clearer idea of that. But if you're happy with those three, let's carry on and look at velocity. So both kinds of velocity are vector quantities. And we'll have a look in the next video about how that makes velocity different to speed. So we'll start off with average velocity, which is the simpler of the two. So the thing I'd like you to note down is our description of what average velocity is. So we usually give it the symbol v with a subscript AV, so we can be clear that it's the average velocity, not the other one. And it's the displacement of an object, which has a symbol s, which can be confusing because people think it is speed. And it's the displacement divided by the time that displacement took to occur. So this is commonly expressed using this equation. So average velocity is displacement divided by the time taken for that displacement. So do pause this video and add that to your notes that we're collecting as we're going through this video series. So just to add a little to that in terms of what average velocity can tell you and what it can't tell you. So average velocity cannot tell you what an object was doing at a specific moment in time. What it's for is to tell you over a period of time what generally was an object doing, what was its average velocity. Its name kind of says what it's doing. So the opposite of that, so the thing that does tell us what an object was doing at a specific moment in time is the instantaneous velocity, which is usually abbreviated to just velocity. So I'll actually put that in brackets because we don't usually say the word instantaneous, even though we mean it. So again, something to add to our notes. So velocity, or instantaneous velocity, which has the symbol v, is the rate of change of displacement. And as I said in the previous video, in physics, if we see the word rate, we're talking about the gradient of a graph with time on the x-axis. So for velocity, on the y-axis, we have displacement, and then you can see there is time on the x-axis. So another way of saying velocity is the rate of change of displacement is to say that instantaneous velocity is the gradient of a displacement versus time graph. And through the video, you'll see me, whenever I'm referring to a gradient, I'll use the symbol m for brevity. So from this displacement versus time graph, we can actually describe what's happening to the velocity. So in this blue, you can see the gradient is increasing over time. So the velocity therefore is increasing. Red, the gradient is the same the whole time because it's a straight line. So that's constant velocity. And the green shows the gradient decreasing over time. So that's showing decreasing velocity, essentially. So we've seen how we can calculate average velocity using a fairly simple equation. So the question is, how do we calculate instantaneous velocity? Well, if it's a straight line graph, that's fairly straightforward. We find out what the gradient of that straight line is. So how do we find a gradient? Well, we do change in y over change in x. So on this particular graph, we've got that it started at a displacement of 0 at time 0, and it ended up at a displacement of 9 meters after 4 seconds. So what we can do is we can calculate the gradient. So change in y is 9 minus 0. Change in x is 4 minus 0. So our gradient, or the number of the gradient, is 2.3 meters per second. But remember that velocity is a vector, so it needs both a magnitude and a direction. So that's why you can see the subscript v in here. So what that v there is indicating is that this is the displacement in the vertical direction, or like displacement upwards, if you like, which is how I've been able to give this 2.3 vertically here. So we use a lot of subscripts for that kind of thing. So that's if we have a straight line graph. But what if we don't? What if we have what's called a nonlinear graph or a non-straight line graph? It's maybe something like this. So this nicely highlights the difference between average velocity and instantaneous velocity. So let's say we want to know both of those velocities at 5 seconds. So average velocity is fairly straightforward. We find the distance, which you can see here, and we divide that by the time, which we know is 5 seconds, and we get an average velocity of 4.4 meters per second. And strictly speaking, it should have a direction. So let's say we're now working in the horizontal direction. So if you see a subscript h, and it's positive, then it's positive in the horizontal direction. So that would mean it was to the right. If we want to know instantaneous velocity, we would need to work out the gradient of a tangent to the graph at 5 seconds. So this dashed line here, you can see I've drawn already the tangent to the graph. And if we want to find the gradient, we'd need to know another point on that tangent, which you can see I've marked in here. So then we can find the gradient of the tangent. So we're going to do change in y divided by change in x, and that gives us a gradient, which is 3.3, which again we can say is to the right because it's positive and we're doing displacements in the horizontal direction. And by convention, a positive displacement means displacement to the right. Okay, so that's how we calculate instantaneous velocity with a nonlinear graph as well as a linear one. So what we're going to do, as we usually do, we're going to finish off with some summary questions that I'm going to get you to have a go at. So what I'd like you to do is pause the video and on a rough piece of paper, have a go at each of these questions that you can see here. And then once you've done that, you will then go through them and see what we should have. Okay, so now you've had a chance to do that, I'll give myself some more space. I don't need it to fit on screen anymore. So let's start off with similarities and differences between average velocity and instantaneous velocity. So some similarities is they're both vector quantities, so they both have magnitude plus direction, and also they're both measured in meters per second squared. Second squared? No, they're not. Meters per second. That would be an acceleration if it was meters per second squared. in terms of some differences between these, so let's actually talk about what they are. So average velocity is the displacement divided by time, whereas velocity is the rate of change of displacement. So average velocity tells you what it's been doing over a period of time. Instantaneous velocity or velocity tells you what it's doing at one moment in time. That's the kind of the key difference there. So let's have a look at describing this graph because we've got quite a few things that we need to include there. So first of all, we've got a positive gradient that's decreasing. So let's say we've got a displacement in the vertical direction, to be more specific. So positive would mean it's going upwards. So initially the object has positive, which means upward in the way I've defined it, decreasing velocity. How do we know that? Because the gradient is positive but decreasing. The velocity becomes 0 because the gradient becomes 0. The velocity then becomes increasingly negative. What does that mean? That means it's going downwards and it's getting faster. The velocity then decreases to 0 here. So we're now at this point on our graph here. And then the velocity becomes increasingly positive. So again, or we could say it's upwards because I've said we're looking in the vertical direction here. So let's label our sections so we can match them up. So this is section 1. Velocity becomes 0 here. Increasing negative is here. Decreasing to 0 is in here. And then finally, velocity becoming increasingly positive is this section we can see here. Maybe at the end we could also give a stage 6. That looks like it becomes this. The velocity becomes constant and positive again, which means upwards. So you can see here it becomes a straight line towards the end. So maybe we could add a 6th step in there. Okay, so let's look at calculating each of our velocities at time is 10 seconds. So to do the average velocity, that's fairly straightforward. It's just displacement divided by time. So you can see at 10 seconds, it's been displaced 23 meters upwards. Divided by 10 gives us 2.3 meters per second upwards because it's positive and we're dealing in the vertical direction. Instantaneous velocity, we would need the gradient of our tangent, which is why we've got a tangent drawn in there. We'd do 23 minus 7, and we would do 10 minus 8, giving us 16 over 2. So it's 8 meters per second. Again, it's clearly positive at that point, so that's going to be upwards to make it a vector quantity. Okay, so the final thing, as I do in a lot of the videos, we're going to look at the notes that I've taken from this video. So there's not much new that we needed to note down in this video, just the 2 types of velocity. And then again in here, we've got our cues to help us remember the keywords in future. So we've got that our average velocity, so that's our symbol, is displacement divided by time. So easily I've given myself the key words there. And this velocity, which is instantaneous velocity, is the rate of change of displacement, or it is the gradient of a displacement versus time graph. There. So we've just got our cues to help us remember those, which I will make use of in subsequent videos. So that brings us to an end of looking at average velocity and instantaneous velocity. And in the next video, what I'm going to look into is how is speed different to velocity, and how does that change how those 2 things behave once we start doing calculations with them. So that's what we'll address in the next video.